Okay, and in question 5 we've got two functions set up with their domains. We have to start by stating the range of f. Now, the range of a given function, if it's not an inverse function, you're always best off thinking of a graph, although it is possible to think about all the x's greater than or equal to 2 and think about what possible answers you might get to the square root of x minus 2. Or you sketch this graph. It's a transformation of the graph of root x, and you decide what y values are possible, and you state the range by describing not x. Possibly y would work, but what they really want to see is the range of values f of x can be, so use f of x when describing the range. In b.e1, re-entry point, you don't need to have done part A. Find fg of x. Well, that means f acting on g of x. Here's g of x, so you can substitute that in first, and then f has to act on that. Use examples from your notes to set that up. But once you've got the answer, in .e2 you've got to solve that equals 1. So your answer to b1, solve equal to 1, just do normal algebra and follow it all the way through. I don't know how many solutions there will be to that. Make sure you don't lose any if there are more than one. And then in part C, another re-entry point. Here's the function f. We've got to find its inverse function. So you start with y equals this. For the inverse function, you swap x and y, and then you rearrange to make y the formula. But your answer has got to be f dashed of x equals the expression. Make sure you put this back in so you've expressed the answer properly. Examples of that in your notes though.